Welcome everyone to the part 1 of the ENEL 351 project series. Today we dive into the exciting world of assembling our two-wheel wonder, a line following and ultrasonic obstacle avoidance robot car. But wait, we're not just following the crowd, we're pushing our boundaries with the STM32F103RB microcontroller, stepping away from the familiar Arduino path. In this video, you'll witness the process of putting together the hardware. I'll be sharing insights, tips, and tricks as we assemble our robot, ensuring a smooth journey for the beginners. And here's a heads up, this is my first crack at such a project, so it's not perfect. I made some mistakes along the way, but fear not, as I have captured those moments and shared how I fixed them in this video, making it a learning experience for all of us. But that's not all. Stay tuned for part 2 and 3 where I'll showcase the exciting upgrades I've made along the road. Each video will dive a little deeper into the evolution of our project. In the upcoming videos, I'll be explaining the coding part of the project, guiding you through the process step by step. Whether you're a coding pro or a novice, hopefully I've got something for everyone. So buckle up and join me on this thrilling journey of coding and building. Let's bring our ENEL 351 project to life, one upgrade at a time. Don't miss out, stay tuned for more. Step 1 of this project was to assemble the wheel motors to the body of the mainframe of the car. Step 2 was to assemble the L298N motor driver onto the body of the car. In this part, I'm connecting the red and black wires to the L298N. However, I encountered a teeny hiccup. The wire endings on the motor were a bit too short for comfort, but I skillfully handled the situation by delicately cutting the wires, extending them to ensure a seamless connection. For your convenience, I've attached the wiring diagram on the left side of the video. This visual aid will guide you through the process and make it even easier to follow along. You will also see me wrapping the wires around the brass cylinder before connecting them, just so the wires are less visible from outside and good to look at. It's all part of the learning process, and I'm excited to share these moments with you. Here I'm connecting the long brass wires on top of the body just so we can put the secondary level of the car body on top of it. Next up, we're diving into the assembly of the servo motor. A crucial step for the ultrasonic sensor as it will sit on top of it. Now, I have to admit that the manuals that came with the kit led me on a bit of a wild goose chase, but I had to figure it out the hard way after catching the error and had to improvise to get things back on track. In this project, I had to figure out many unexpected twists that I faced, and I'm sharing my improvisation techniques to correctly connect the servo motor. It's a testament to the unpredictable nature of DIY projects. Let's turn this challenge into an opportunity for learning and problem solving. Stay tuned and let's see how we conquer the servo motor assembly together. Next up was to assemble the front universal roller, which seemed pretty straightforward by following the manual. However, as I completed the build, a bit of a surprise awaited me: extra brass cylinders. Rather than scratching my head in confusion, I decided to turn this into an advantage. I strategically added these extra cylinders to the front, giving our robot a bit more height. Why the modification, you ask? Well, our infrared sensors needed a downward view to efficiently track the line. I did this on-the-fly adjustment and transformed an unexpected situation into an opportunity for customization. This is the beauty of DIY, adapting and optimizing as we go. Stick around to witness how this small tweak makes a big difference in our project. As we move forward in the assembly process, the next step is to connect the ultrasonic sensor to the plastic mount. This mount is a crucial component that will sit atop our servo motor, allowing it to move 90 degrees in both directions to scan for obstacles dynamically. This setup will empower our robot to scan its surroundings efficiently, paving the way for obstacle avoidance functionality. second base of our robot, which will house both our power source and the brains of the operation, our STM microcontroller. The kit initially included a power supply that required two 18650-volt lithium-ion batteries. However, when I saw that a pair of these batteries cost almost same as the entire project, I decided to explore a more economical alternative, which is a two 4 AA battery holders connected in series, providing a total of 12 volts. This solution not only saves a significant amount of money but also offers the convenience of using batteries readily available at any dollar store. It's a practical choice that keeps our project budget friendly without compromising on any performance. Let's talk about a creative modification to our infrared sensors. While the kit's default use for these sensors is for infrared obstacle avoidance, but we're taking a different route. We're using them for line following. To adapt them to this new purpose, I had to get a bit crafty. Spotting the screw holes meant for sensors during assembly sparked a creative idea. I repurposed my old student ID, cutting pieces and adding custom screw holes to fashion mounts for the sensors. In the next video, I'll be gluing the sensors on them. This tweak allowed us to optimize the sensors for line following functionality and also added a personalized touch to our project. As we wrap up part 1 of our assembly journey, take a moment to admire the end product that we have crafted together. The robot is taking shape, and there is much more to come in the upcoming videos. Stay tuned for the next parts of the video series, where we'll explore exciting upgrades, tackling code challenges, and continue to enhance our project. Your curiosity and enthusiasm drive this exploration, and I can't wait to share the next chapters of our robotic adventure with you. Until then, happy building and stay tuned for more.